In today's class, friends, last class I remember we were discussing on decision trees. And in today's class, we will continue with our discussion. We will discuss on random forest, right? Once we get a random forest, then we will come to the example of evolution analysis. But this is a very important topic, friends. Most interview questions are asked on random forest decision trees. So please pay attention if you are doing something simultaneously. I would encourage you to stop doing simultaneous work and start focusing on today's topic. So what is random forest, friends? As the name says, friends, random forest, when you say forest, when you say forest, there will be multiple trees. I'm using green colors so that it is right. So there is not only one tree, but it will have multiple trees. Last class we have studied decision trees, but in this class we will build decision trees and random forest are called ensemble method, right? So in a forest, like how multiple trees are there, likewise in random forest we will not use only one decision tree, but we will use multiple decisions, right? That's the idea again of this forest, right? Random because we are creating random, we are creating, passing random values to these trees, right? Imagine this is my starting point. Right? Let's say I have those chords, right? I will pass to one decision tree. This itself pass to one decision. Underneath it may have it may have here I will pass some thousand. Here I will pass some thousand, and here I pass some other to this tree, right? Likewise, I can create multiple trees, right? So you may ask yourself, stop all these things. That's why you want to create multiple trees. One tree is not enough. A tree itself has multiple branches, right? Friends, for example, if you want to purchase something, right? What you will do, you will not ask one person, imagine purchase a laptop, right? For data science, you are buying a new laptop on two version. So what you do, you will have multiple person. You will ask your relatives, right? You will ask your dad, right? You will keep on. There are some people keep on. There are some keep on asking their friends, other people, right? And there is sometimes they will look for Google reviews and so on. So if friend says, friend gives out of seven, you are planning to buy a Dell laptop, right? Or a Mac or whatever. The friend says, it recommends 9 out of 10. Hey, man, go man. Go and buy Dell laptop. It's good. It's Windows one. Your relative says, I do not buy. I already have a Dell laptop. It has issues too. Or others, some other person, right? He says online, let's say, it says 8 out of 10. And Google review for Dell store on Amazon, right? Or Google review by on where you see the product is determined. So what you do, friends, you add these 4 items, right? Since there are 4 items, right? You'll have this 9 plus 7 plus 8 and then take average out of it, right? And that's what you do, right? Whatever the values you get, based on that you have a decision saying that if my values is above 8, right? Then I'll buy, right? So in this case, 9 plus 18 will be above 8, right? So you make a decision, let's buy it, right? So likewise, same ditto, the companies also make a decision. They doesn't just make decision of one thing. They take multiple inputs. They look at the market. How is the stock market? How is the economy in that country, right? Say, for example, I may want to establish an office at your place. They will look at who is it government, how supportive is the government for IT, right? So all those things they will calculate and make a decision. So in this case, everyone, maybe your friend will say so many factors. Based on this, all your friend may act like a tree, right? Your relative may act, you may ask two, three, you will ask your uncle, aunt, and your brother-in-law, you keep on going, So, right? To make one decision, actually asking, giving a survey form, to fill that form to multiple people. Right? In turn, they give so many perspectives. So likewise, instead of taking decision from one decision tree, right? What we see this, if we draw this tree upside down, this is my root, right? Friends, from this root comes the branches, right? Likewise, if I put this root upside down, this is my root now, and from it comes the branches, okay, right? Left branches, right branches, all these are there, right? So, one tree, we cannot trust one output, right? So, else we go for right? Since we are combining multiple trees or multiple models together, these are called ensemble. They may ask me what are. So, with that understanding, let's go through our definition. Random forest is a collection of many decision trees. Right? Sometimes in some decision trees you use also other algorithms to do that, but generally they use decision trees. Right? So that's why it's the same way. It's a collection of decision trees, right? And then each tree makes a small decision, right? And put together all these trees, the forest decides by voting, as I said. Right? Just like asking a group of friends for this. I want to explain this again. Yes, understand. So think of it like this: like one decision tree is one person's opinion, right? A random forest is a group decision, and the majority wins, right? So why random in forest? So it's called forest because there are multiple trees, as you can see here. It's called random because each tree is trained on different random parts of the data. As you said, it will have 10,000 records. Your customer may give 10,000 records. But for each tree, you get some random set of results, right? For example, you give you plan to give 3,000 records for each tree, right? Only for the last of the seasons, we have three. It has 3,000. So you will not give the first 3,000. You give the first 3,500 records, and the last 1,000 records you give for this first. The second tree, you give the middle 3,000. And the remaining 4,000 records you give to this tree. So this is why it's called random. You are training on a random data set, right? So this random makes the model more accurate as bias. So since it is trained on random data, the model will become more and more accurate. Since you are not giving a new sequence, you're giving out of sequence as random. Right. Yeah. So simple analogy, suppose if you want to, I already said this analogy, so I'll just click this. So let's go into our example case study. Let's take Titanic case study. Right? This is a real data set, right? You know the story of Titanic movie, that the Titanic ship disaster happened. And this is really a point by itself, right? You have the passenger class. So if you see the movie, some people might have traveled in one class, like first class, second class, third class, and so on. And you might have seen both genders, namely male and female, have traveled. Age is in years, right? And fare is ticket price, right? and survived or not survived. Survived is if the person have escaped from the disaster, then it's one. If they have not escaped from the disaster, then it's zero. So our goal is to predict whether a passenger survived or not. So imagine the disaster happened just a few days ago, right? There nobody has gone into the deep sea, right, to recover that ship, right? It's very hard, right? If it's flying, you can see on the land, but it's deep inside the water, right? You have the passenger list, and you want to predict like this person might have. If that's what the newspaper does, right? They will say nearly 300 people have died, or right, are missing. 400 people are missing. So all those things. So this is what the bioactive is. So we have already seen all these things and this with this friends for the positive time. Okay, so it's loaded, and then we can clean and prepare the data. So I'm choosing this data. This is my data, which I'm interested in, right? We are looking at passenger class 6, age, fat, right? So we look for the missing values, like any data since project. This is one of the first step, right? If some images are missing, we can fill them with the average, for example. So we are looking at the resolution method, right? This means select the entire age column, right? All the rows for the age column, and then replace this age column, friends, with I will find out what are missing, and if it is missing, I am taking the mean of this age column, right? Mean, let's say there are 100 passengers. So let's say only 3 passengers. First passenger age is 30 years old. Second passenger age is 30 years old, and the third passenger is 60 years old, right? If we add this 30 plus 60 by divided by 3, you make it some other answer. And that answer, like 40 or something, that you use it for every missing value. That's what you value. So next is, as you know, our models cannot understand text, so we are using labeling code. Using labeling code, all the vendors into zeros and ones. The mail is one zero. And next step is between the data training and this. I already said it. What is the training data? You as a data scientist, join Google and product manager use 100% accounts. So what you do, you not just state out train this into feed into the single model. This is a wrong approach. So mostly what you do, you will actually take this sensors into the core and divide this into train and test data, right? You will say that this is the data I'm going to train my baby kind of thing, right? You train your baby like that. You are going to train the model train. So you are going to train this model with some record. For example, usually you will train 80%. 80% of the people means 8,000 record. We will split this data into 2 parts, right? You can like cutting a cake, you will cut it into 2 parts. First part is training the data, and you keep this 2,000 records separate. Then you feed only 8,000 records to ML model. So that this ML model is like your baby, like a child or your brother or sister. And this sister or brother goes for 8,000 question answer yesterday. If in exam they ask this 8,000 question answer, you will secure 100 marks, right? but I want to know whether your brother or sister is good in maths or not. So I'm giving some 2000 marks, 2000 questions, which he has not studied, right? But they are similar questions, right? I'm going to, once this model is built, then I'll take this 2000 record and feed this model to this 2000 record, right? And I'll check the accuracy, right? Whether the model is able to predict 100%, right? For example, for this 2000 records, imagine 1,500 people from Titanic ship have survived, right? Whether your model is able to say 1,500 or it is able to predict 1,200 records will be correctly and 300 records it has classified wrongly, right? It has said they have not survived, right? They have sinked under the sea, right? This is modern there, right? So this is why we give this test data, right? To check whether if I ask the same question, what will happen? The model will say again, I have already studied all these things, so it will say correct 100% only when I give the real data. But companies, they will use test data to check the accuracy of it. So that's what it is. Hope this is clear. Okay, next is, so I'm saying out of these columns, the answer I want, my output should be survived. I want the output surveyed as my result. These are the columns I'm going to use to understand whether the person has survived or not, right, friends? So here I'm splitting this data. They say these are the columns, and then I'm splitting this data, as you can see, friends, into train and test, right? The way I split is I give four variables, X train, Y train, right? X train will take these values, and Y train will take this column alone. Likewise, I split X test, Y test, right? And then I use this strength method, friends, and then I pass this X and Y, which is my input variable. Input features here we call it. This is output or target. This is what I want, right? Then I will give this, and then I will also give you the test size. So if I say 0.2, that means 20% of the data size should be allocated for testing data set, right? And I say random state 2 for it because I want every time to use the same data in this case, right? So that I'll get the same result. So now let's come to our model, right? So right now I am using a random forest classifier, right? This is my model. This is an ensemble method, as I said, sklearn.ensemble. From then I'm putting random forest classifier. So I'm importing this class, and then I'm taking an object of it. Model is my object, and here I'm specifying 50 trees, right? I can also increase my trees, right? Why don't you use 5,000, sir? You may ask, right? If you use 5,000, you must have the capacity on your computer or on the Google Colab, right? Your Google Colab is a free account, so we cannot, depending on the data set, right, friends? We cannot use a higher. So 50 trees we have. And then we say for that every time it will give the same result, right? It's kind of like a seed number. And then this is my object. This model, from this object, I'm calling this fit model, and I'm passing this train and white train. So this will train, like this is model is kind of a student, right? I'm giving the student a test of 40 questions. Sorry, 8,000 questions to this student, like model, right? So if you run this random model with estimate T and random 42, And then, as I said, attempt decision trees, the more the trees, the better the result. Right? Each tree learns from different parts of the data, as we have already seen. Then we look at the accuracy, right? So imagine 500 people have surveyed, right? Out of these 500 people, how many of you are able to correct this, right? You have predicted, for example, 400, say, let's take it as 400, so that no, 500 is also. Let's say I predicted 100, only my model is able to predict 100. Then what is the accuracy difference? 20%, right? Imagine instead of 100, right? It has predicted 200, right, this time. So if it's 200, what would be the accuracy? 40%. Right? Like this 300 is 60%. And if your model is able to predict, 400, right? Then your accuracy is 8%. Suppose 450 and 90%, sometimes it may be 499 something, 99% is able to, that is accuracy, right? In this case, what is the accuracy they are saying? 79.8 previous, right? Let's try this time and check what is the answer difference. Okay, it's like 79%, right? Okay, so with this, how did we get the accuracy? We trained it and then we use this model score. This is my training accuracy, right? Next, so that accuracy is like how much the student has attended. For example, 1 hour class. 55 minutes, 50 minutes the student attended, for example. 10 minutes he went for some other sports event or something, right? That kind of thing is this accuracy, right? Out of this 8,000 sample, the model is able to learn 7,000. Then let's say it's a 8% accuracy. Right, friends? So, likewise, now I'm going to give you a test data. This data is for some student. For example, let's say, call this person. He also boarded in that ship. This person, what is this first? He has traveled in, let's call this person as Bob, right? Bob traveled in third class. He's a male and he is an young man, age 22. And he has paid a 7.25 pound, right? Let's say, right? And then in those days, it's high one, right? So then I will pass this sample onto my model, right? Earlier to train, I used model.fit, but this function is called a model.predict, right, friends? And then I will say if the result of prediction returns 0, then the person did not survey, right? Right. So if prediction is of 0 equal to 1, if prediction, then you say survive, else you say as not survive. So in this case, we'll see this person has not survived, right? Probably we can change this data and we can see, right? Okay, next is confusion matrix. Before that, you will have to understand, you have learned accuracy, right? And this accuracy, friends, will not be good. It will not be a good evaluation metric in terms of problems like spam detection, where in spam detection, we are concerned about both spam as well as non-spam, right? Non-spam or ham, we call it. Spam is not an intended mail, ham is my mail which go to inbox and this will go to the spam folder, right? So we want both the things here. Whereas accuracy will look on only the correctness. It will look on only ham, right? And not the spam. Or spam alone and not the ham, right? Only one class. So to encounter this problem, friends, okay, so for this, we are going to study different metrics. I'm just going to stop my sharing. Just give me once again, I'll reshare. Okay, I think we will reshare and then we'll deal with the problem and then we'll share, go to the analogy. So let's understand this precision recall F1 score along with visualization with our famous spam detection example, right? Right. So let's dive into it. So as usual, I'm importing the necessary libraries. In this case, I'm importing this confusion matrix. We will learn shortly. And then classification report. Here is where we have precision, recall, F1 score, all those things are there. So I'm just executing this and then it says library is important usefully. So this is my spam detection problem, right? So let's go into, I'm going to go to Word just to explain this problem. Hope my screen is visible, friends. So as you can see here, friends, visibility. So this is my data section, right? Here are my labels. Sorry, here are my data. Records, right? So I'm just writing the answer, right? So in this spam detection, there will be only two possible results, right? One is not spam and one is spam, right? Just give me 1 second. Okay. Okay, friends. I hope my voice is audible and still you're able to see my screen. That's right? If it is so, can you please type yes so that I know we are on the right track? There are no issues. If there is no voice issues, then we can proceed. Can you please type yes? You are able to see my screen and my voice. Okay, thanks. Thanks, Payne. Okay, friends. So, having said this, look at this problem, right? I just zoom much more. So, I say this is my true data, right? I got 10 emails from right? Put me in my scenario. My name is Arutya. I'm Arutya. I got 10 emails. My first email This is spam email, right? Since it's a spam email, it's kind of not a good mail. I use this warning symbol, right? My second mail is not a spam email. It's a very good mail. It's intended from a company. It's a business mail, let's say. Third is also uh, a spam email, right? Fourth is spam. Fifth is spam. Sixth is also sixth is my friend has sent a mail. This is from my wife, would say. This is from marketing mail, let's say. And this is also a fake mail. This is from my children, right? So imagine this is I've used this photos. Don't get frightened about these mails, right? Just to denote against, I thought like using these emoticons would be interesting. That's why I use it, right? So this is my actual thing, right? Now, as a data scientist, I've asked you to build what a spam detection model to classify the 10 mails, right? And one of you come, let's say there is one person named Sam, right? Sam is not present here, I'm just saying, building up some name, right? So Sam built a model, and this model says the first mail is spam, right? Second mail also is saying this prediction is saying spam. Third is also spam. Fourth is not spam. Fifth is spam, and then sixth is not spam. Like that, he is saying. So now, I want to calculate the true positive, right? The true positive is, let's consider only the spam thing, right? Let's consider. So I'm just not going to look into this not spam. So I'm just cycling out. So out of this prediction, how many of them are right? Right. So he has predicted Sam. Sorry, first record as spam. Yeah, it is right. Good. Second record, no. Third record, right. Okay. Fifth record is also right. Okay. Ninth record is also okay, right? So this is called true positive. So in my prediction, how many of my predictions for my spam class, for example, is right? That's called what? True positive, right? Oh, this is visible. True positive, right? I have in POS, but it's true positive. And the opposite is the false positive. So in other words, I will choose. I choose like what are the things it has done wrong, right? This is not spam, but it has detected spam, right? This is wrong. Likewise, this is also wrong, right? Likewise, this is also wrong. So this is called a false positive. Right, so sorry about the interruption. So this is what the false positive is. Hope this is clear. This true positive, false positive, right? So with that understanding, friends, let's move further. Next is we will earlier we were looking on only the spam class, right? Now let's look into the non-spam class, right? So if we look into it, just give me 1 second. So we will look at the true negative, right? So I'm just going to strike out all these things. For simplicity, I'm not going to look at this thing. Only non-spam class I'm going to look. So spam classes and all I'm striking out. So on this non-spam, I'm just checking like how many of them it got it right, right? This is not spam, and the truth is also not spam. So this is right, right? right? Whereas it is saying the sixth mail is not spam, but it's actually ham. This is the right mail, right? So this is wrong. So I'm not going to look into it. And uh, sorry, uh, I have got. So this is not spam. It's actually spam. Warning is spam, right? This is wrong, right? This is not spam. Yeah. This mail heart is not a spam, right? So I'm saying this is correct. Likewise, this is saying it's not spam, but it is actually a spam, right? So this is also wrong. So only one record I got it right. This one record is called true negative, right? How many of them I've got it of the negative case? How many of them I've got right? Right. Likewise, on the false negative, I will not look into this. I will look into like how many of them you got it as right. This is not spam, right? So, sorry, how many of them are false, right? False negative, right? So in this case, this is one false negative. Likewise, this is also one more false negative, right? That case will not, while looking at false negative, will only look at the negative thing, right? Hope this is clear. So the next thing is we have studied accuracy, right? Accuracy is like we'll not look at one class and what we do is, friends, this is my true factor, right? So, for example, you don't consider positive or negative or not. We'll just look at like spam, yes, spam. Not spam, this is wrong, right? So, I will just say this is wrong, this is right, this is wrong, this is right, and this is also right, this is wrong, right? And not spam, this is also wrong, right? This is also wrong, right? So I'm not looking at this spam plus or not spam plus. During accuracy, I look at the overall thing, right? So here, if you count, there are five is the number of things we got out. So we'll say five by total items. Total items is 10, right? So we'll say 5 by 10. That's what it is, right? So it doesn't matter positive or negative. So this is clear. Next, having this understanding, you will understand, will study precision, right? Precision is like precise, right? It is always about predictions, in other words, to remember, right? Uh, formula for prediction is true positive by true positive by false positive. So in this case, it will be 4 divided by 4 plus 3, right, friends? Which is 4 divided by 7. This is my what we call as precision. This is very important, friends. So I'm going to highlight this. Right? So we have built all this knowledge just because to learn this precision. Right? Whereas recall is if you look on the baseline, I think that's the baseline. For example, we have out of this total spam truth samples, how much we got, right? Total spam truth samples, right? So this is my two samples. In this, how much spam? 1, 2, right? 3, 4, right? So they are just saying, look on to only the total spam, right? So we're going to not consider this not spam at all. We are looking at the spam truth samples, right? How many samples are there? While the precision look at this Y prediction, truth recall looks at these things, right? The true case, right? So in this case, how many spams are there, right? 1, 2, 3, 4, 6 are as per my white truth column, right? So that's what it is doing, friends. So, but when I predicted, I got only 4 true positive right. That is 4 spam mails right? So as you can see, only 4. There are 6 things, but only 4 are they got it right. So recall is 4 by 6, right? In this case. So and then this is the formula true positive by true positive plus false negative. Okay, so now let's go back to our code friends. So I've explained baby steps so that you understand this is our problem. So this is our code. This is I'm just getting the data ready. And then we will run confusion matrix. We'll look into confusion matrix shortly. So here 4, as you can see, is true positive. And this is true negative, right? So true positive versus false positive, and then true negative, false negative. That's what it is. In other words, friends, in these diagonals are important, right? This is what, for example, let's understand this. This is what confusion matrix is all about. There are actually 4 mails from Arukia in his inbox, which are actually spam. And you also predicted that it's actually spam, right? But here, they are actually not spam, but you are predicted as spam. Likewise, here also, this is not spam. This is spam, but you are classified as not spam. But this one is actually spam, so not spam, and you are also calculated not spam, right? So that's what it is. Okay, friends. So, with that understanding, let's execute this code. So, as you can see here, true positive, this is what the values are, right? So, we are building the data, we are mixing. Yeah, this is what the confusion matrix, this is what we are trying to build. I've explained that the color graph is a confusion matrix, by the way. Okay, so and then whatever I explained for not spam, they are calculating individually what is the precision, what is the recall, what is the F1 score. Likewise, spam also, if we consider only the spam class, what would be the precision recall? I'll tell for F score. F1 score is nothing but the harmonic mean. We'll see that. So when you use this classification report class and if you pass this Y2 and Y prediction, just now I shown, if you pass the value, you get all this accuracy also, you get 0.50. So we are calculating F1 score for this repository. Yeah, so with that, I think likewise we have for this data, this is the fiction models for our what is that Titanic data set, right? Okay, so these are the steps we have done. With that, I'm going to stop here. If you have questions, friends, you can ask me now. You can type on the chat. If there are no questions, I think we are good to go. Next class, you will see other topics. Anyway, thank you for your time, friends. On Sunday evening, while your friends go outside and enjoy a weekend, you take time to upgrade yourself. I wish that you get a very good job in the future. So you finish your graduation, right? By doing this. Thank you, friends. If you have questions, I'll wait. You can type your questions on the chat.